In this final little segment about tracing the paths between workloads that are on Tier 1 gateways with SRs, Tier 1 gateways without SRs, I'd like to show you a little pathing using the path topology that vRNI can have to sort of outline what takes place when two machines want to talk to each other. And we'll finish it up with a quick look at wanting to go to the internet. So let's take a look, shall we? The little diagram here that I've got outlining the lab that I'm going to point to you has two green segments that belong to a environment referred to as Middle Earth. And then I have two light blue segments that are in an environment called lab. So I've got one with an SR, one without an SR in the lab environment, and then I've got one with an SR and one without an SR in the Middle Earth environment. Now Balrog is connected to a switch that is connected to a router that has an SR. Bagend is connected to a segment that does not have a Tier 1 gateway that has an SR. Web 1, the web tier, has an SR. The app tier does not have an SR. Let's take a look at what that looks like in the topology, the path topology that vRealize Network Insight can share with us. So in vRealize Network Insight, we have a path from here is Balrog, and there is Web 1. So if we watch the path, it will travel to the DR component of the Tier 1, and then it will hit the SR. The next step, this backplane transit network, takes it to the SR, which will then go to the Tier 0 gateway and forward it to the Tier 1 SR for lab. Now, Tier 1 SR and DR work together and share its routing information, so he knows that the connection will go directly to the logical port on the web tier or the logical switch. And then it forwards that traffic to Web 1. If I reverse this path, it pretty much mirrors. It's going to go DR to SR, SR to Tier 0, Tier 0 to SR, and deliver. Let's just make a change and look at the path if we did the backend machine, which does not have a virtual an SR component, to go to app 1, which also does not have an SR component. These two are on the same host just like the other two, but there was no SR. So now I'm going from backend to his DR, to the Tier 0 DR, to the other Tier 1 DR, and then to the logical switch. So here, fortunately, I never leave the host, the transport node that's in question. I could reverse that path and end up with the same environment. I don't change because of the distributed only. There's no SR involved with these two workloads. They're on segments that do not share an SR component of the gateway. So that is a major difference. But backend to the internet goes my DR to the Tier 0 DR to the Tier 0 SR and out. Now Balrog has an SR. Let's see how he gets to the internet. Balrog's path to the internet is going to go from his DR to the tier 1 SR on the edge. The SR on the edge is going to communicate to the SR on the tier 0 and then out to the internet. So I had 2 steps locally for bag-end because bag-end had no SR, and only 1 step locally for the outbound traffic when an SR is involved with the tier 1. I bring this to your attention so that you can see a difference it makes when you're operating with or without a service router component on that tier 1. Planning purposes would say, if I need stateful services, I absolutely have to have an SR. My traffic is going to be influenced by that with regard to utilizing the edge for more of the traffic for that particular segment when it's attached to a tier 1 gateway that has an SR. I think you need to be aware of that as you set up your NSX-T data center deployment. Hey, ping me if you've got any questions. I'd be happy to try to answer them for you or guide you in the right direction. And thanks once again for spending a few minutes at vGandalf Demystifies.